Hey everyone, welcome back again to HSP in World of Chemistry. All ionic equilibrium formulas with just two lines. Now you must be thinking, sir, is it possible? Yes, my dear friends, I will let you know just in 5 minutes all confusing formulas. Let's kill it. Okay, just see. One line is standing line. Either we are in standing position or we are in sleeping position. So one is standing line, one is sleeping line. Just remember, keep it in your brain. Standing line and sleeping line. Same. Next slide. Now see, alpha. Alpha is known as degree of dissociation, DOD. In Hindi, dod, DOD, dod. And for dod means to run, we have always to be in standing position. Okay, standing line. We have to remember this standing line. And whenever we want to concentrate, for concentration, we lean down. So we need sleeping position. Okay. For alpha, standing. For concentration, sleeping. Just see, Kasi. Here in standing line, Kasi. Here in sleeping line, Kasi. Okay. For weak acid. For weak base, if you want to find out alpha, that is for weak monoacidic base, Kasi and KBC. Sorry, KBC, KBC. कौन बनेगा करोड़पति? So here standing Ka by C, here sleeping KAC, right? This is the most confusing part. If we are going to do the derivation, we are not having that much of time in our examination. So remember that. Kasi, 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 standing Kasi, sleeping Kasi. Standing Kabasi, KBC, sleeping KBC. Got it. First slide is clear in your brain, kids. All the questions for weak acid, monoacidic, and weak base, basic acid, monoacidic base. Is it clear? Yes, sir. Now, next is salt hydrolysis. This is the killer part. People are always getting confused in this killer part. So first we have to know that type of salt, whether it's a type of strong acid, strong base, weak acid, strong base, weak base, strong acid, weak acid, weak base. Oh my God. So here is the formula. Cation. They are responsible for strong base, sodium, potassium, and barium 2 plus. Anion, they are responsible for acidic part, chloride, bromide, iodide, nitrate, sulfate, ClO4 negative. Okay. So any combination of these salts means that cation and any anion from here will make salt of strong acid, strong base, which will never show salt hydrolysis. Rest of three salts will show salt hydrolysis, and for them we have to find out each and everything. Now let's see another slide. These are the four types of salts. 1, 2, 3, 4. This salt will never show salt hydrolysis, so it will not have any formula. So NaCl, NaBr, you can say Na3, salt, NaNO3, or you can say KBr, you can say K2SO4. All they belong to this category. NaClO4, KClO4, NaCl, KCl, Na2SO4, K2SO4, barium sulfate, all they are that category salt. Now here, this is strong, but this is weak. Means this part should not be from that table. Okay. So sodium acetate, this is strong from the table, but this does not belong to the table. So it is salt of weak acid, strong base. Now weak base, strong acid means this should not be from that table, but this should be from that table. Ammonium chloride, the anion part, the acidic part is from the table, but this is not from the table. Now weak acid, weak base means neither of the cationic nor of the anionic part from the table. CH3COO NH4. So see, this is not there, this is also not there. So number of examples you can frame out, but I have written only few which are most important for your examination. Now see, kids. Okay, Now, degree of hydrolysis, it is just like alpha. For salt hydrolysis, we will use a small h. Small h is just like alpha, 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 right? There it was degree of ionization or degree of dissociation, but here it is degree of hydrolysis, but same thing. If you want to find out its value, alpha, I have told you the alpha was here standing line. So here also standing line. There for acid it was Ka by C. For base it was Kb by C. Weak acid, weak base. Here it is Kh by C because we are talking about salt hydrolysis. Okay. This is very, very important, which holds a hell lot of weightage. Now see, my dear students, hydrolysis constant Kh, because there is Kh. For weak acid, it was Ka. For weak base, it was Kb. Here it is Kh. Okay, there it was Ka-C, Ka-C, Q-C. Weak acid, K by C, Ka-C. Weak base, Ka-C, Kb by C. Now for salt hydrolysis, Q-C, Kh by C. Now, how to find out this Kh? Kh is equal to Kw. Remember that Kh is equal to Kw. What should be in the denominator? Whatever is the weak part. Remember that, whatever is the weak part. Let's see. If I talk about salt of strong acid, strong base, nothing is weak. So no formula, no salt hydrolysis. But if I talk about hydrolysis of weak acid, strong base, weak acid, so what should I write here? Weak acid. So Kw upon Ka. Now here, weak base, strong acid, weak base. So I will write Kb. Now here, weak acid, weak base, Ka into Kb, right? Whatever is weak will be in the denominator. Now, pH of salt. Just remember two things. You know that whenever you are studying in your school, I don't know about your time, but I know my time. Some people were in A section, we were thinking they are very positive, they are very intelligent, and B section, we were thinking B was bad. Nothing is like that, but in my time it was like that. But it is not having any relation with these sections. Okay, A is awesome, positive. B is bad, negative. Just remember two sign, positive, negative. That will give you all the formulas. Now see, pH is equal to, for weak acid, whatever, we have to concentrate on the weak only. Whatever is the weak part, that we have to concentrate, because the salt hydrolysis will just capture the weak part only. That is the hero over here, that weak part, right? Weak acid. So pH is equal to half of pKw, that is 14, plus pKa plus log C. Why Ka? I said A is awesome. So A is always positive. When that is positive, then log C will be positive. And in this bracket, only three people, three entities can remain over there, right? What I'm saying, whenever A is coming, A, how A will come? Weak acid, that means A will come A. And whenever A is coming, it will always be positive. Whenever B is coming, weak base, it will always be negative. When it is negative, log C, minus log C, minus, minus. Okay. Now, both are weak. So only three people can live. So who has to go? Concentration should not be present over here. Now pH is equal to half of pKw. A will be positive and B will be negative. So plus pK minus pKb. Now in this way, always you will remember these formulas, because in the examination we are not having half an hour to do the derivation, and this is the place where people are missing their marks. So remember that if you want to take a screenshot, you can take A is awesome, B is bad, awesome positive, B bad. So this weak acid and weak base pH is independent of the concentration. Many times they have asked the question that if we are adding water, we are removing water, what should be the change in the pH? So no change, because it's not involving any concentration term, right? Now, last but not the least, this is the table I'm sharing with you on the basis of behalf of whatever I taught you right now. And remember this one, if we are having equal or you can see equimolar of concentration of weak acid and its salt with a strong base, of weak base and its salt of strong acid. Then we have to use buffer solution formula that is given by Henderson's Hasselbalch, that pH is equal to pK plus log of concentration of salt upon concentration of acid. If they are giving equimolar, so this will be equal, so log 1 will become 0. So pH is equal to pKa, and pKa is equal to minus log of Ka, if by chance not given. So this is acidic buffer, and this is basic buffer. POH is equal to pKb plus log of concentration of salt upon base. If that is equal, then pKb is minus log of Kb. So I hope you have got it. But remember one thing, very, very important thing. Sometimes they are not giving the, better to say, means in the right way, right approach. They are giving something confusing one. That means they are means just adding 2 chapters, and they are framing out the question from mole concept and ionic equilibrium. For example, if they are saying that I am having 1 molar solution of acetic acid in the beaker, 1 molar, and suppose 100 ml. So milliequivalents are 1 into 100, 100 milliequivalents. And if they have added NaOH, and that is 50 milliequivalent, 50 milliequivalent NaOH is a limiting reagent that will neutralize 50 milliequivalent of acid. So weak acid is remaining and its salt of strong base has been formed. This is buffer solution. Case number 1. If to the same 100 milliequivalent of acetic acid they have added 100 milliequivalent of NaOH, so nothing is a limiting reagent, both will neutralize each other, salt and water will get formed, and salt will be of salt of strong base weak acid, CH3COONA, and CH3CONA means weak acid and salt with strong base. We have to apply this formula. When we have to apply which formula, remember that. Case 1, they added half of the base to the acid, we got buffer. When equal amount they have added, we have got salt. So in this way you will get full marks. All the best, my dear students. Anything else you want, do let me know in the comment section. Your Baba HSP, always for you kids. Bye bye.